Alright, the following question corresponds to number 39 on page 167, and it's asking you three things. To find the spring stiffness, Young's modulus, and the stiffness of the interatomic bond. You are given the diameter, mass, how much the spring has compressed, and the density. To find the spring stiffness, you had to use the equation F equals Ks times X, where F equals the force, Ks equals the spring stiffness, and X equals the length of how much the spring has compressed or stretched. So Ks equals F over X should give you the spring stiffness. It's important to note that from the question, the tension force is equivalent to mass times gravity. Because net force is 0, these forces have to cancel each other out since there's no other force in the acting on the system. So after the calculations, your answer is 57,750, and the units are newtons over meters because Ks is a ratio of force over length, which is newtons over meters. To find Young's modulus, you had to use the equation y equals stress over strain, where stress represents the tension force over area, and strain is just delta L over L. Tension force over area has the units of newtons over meters squared, and the units for strain is m over m, which are dimensionless. So the units for Young's modulus should be n over m squared. In this specific question, it gave you the diameter. So once you find the area, which is a cross section, you had to do pi r squared. So you take half of the diameter and you square it. So after you solve for y, your final answer should be 1.998, and then e to the 11th, and the units are newtons over meter squared. Sorry. Lastly, to find the interatomic bond, you use the equation y equals ksi over d. After you rearrange, you get ksi equals y times d. And once again, when you multiply y times d, your final unit should be newtons over meter. So that's it. One last thing, if I didn't mention before, if the net force on this system wasn't 0, it would accelerate downwards because the normal force wouldn't support it. Since these are the same, the net force does equal 0. But if they weren't, it would accelerate on whichever direction it has the highest force. So here we go.